Welcome everyone. My name is Karen and I will be your host for today's webinar, part 2 in our series of IoT best practices for developing smart connected products. And today's discussion will be with our IoT team, who will be doing a deep dive into IoT design challenges, focusing on power management, security, and engineering for delivery. It is my great pleasure to introduce our IoT pioneers. They will be sharing with you the key learnings and strategies in implementing IoT systems. Some of you have already met Erik, our CTO. Erik Ljung's 10+ years and breadth of experience from mobile platforms, software, middleware, frameworks, 3D graphics rendering, to working with low-level drivers, connectivity and integration makes Erik an early IoT pioneer. Erik will be moderating today's discussion. First presenter will be Warren Fox, who is one of our power management experts. Warren has 25 years experience as an architect and developer of power optimization, and he's worked with clients like DARPA, Hughes Aircraft Corporation, University of California, and is part of the Goji Smart Locks development team. Our security expert is Rickard Eneqvist, with 20+ years experience as architect and developer of mobile networks, mobile devices, with a focus on security, new technologies, technical advancements, and applications. Rickard has worked with L3, Nokia, Samsung, DARPA, Sony Ericsson, Toshiba, Qualcomm, and is also part of the Goji Smart Locks development team. Dr. Rocky Sharp, PhD, is one of our IoT solutions architects and will be weighing in on how to engineer for IoT production systems. With 15+ years expertise in every technical discipline of IoT systems, from firmware to mobile app development, cloud and connectivity interactions, working with clients like Amazon, DARPA, Freescale Semiconductor, and Goji Smart Locks. Rocky is the solutions architect and project manager for the Goji Smart Locks project. So, without further ado, over to you, Erik.
All right, thank you, and welcome everybody. So to set the stage here today, I just want to reiterate some stuff that I've been talking about in the past, which sort of leads to the more in-depth areas of power, security, and how to put the things together. So look at this slide. I think this is very telling to what IoT is going to do to a lot of existing markets. We've taken the lock because it's close to our heart, but the basic lock has been around for 4,000 years. But adding the multiple dimensions of making it an IoT and a smart connected product, now we're facing totally different complexity how to put this system together. And that's what we're going to talk about specifically around power security today. Some of the typical things that we see in IoT, there is still no real good reference architecture. There's a lot of different ways how you put together a product like this, and obviously that opens the door for common pitfalls and stuff, and we're trying to cover them today. Another trend that we're seeing is, working in a project like this with a small team, you see the different development life cycles and how it's different from spinning hardware to fixing a bug in a mobile application. And as a solution architect or a product owner or a lead engineer, you need to be sensitive how you make this all work together. At the end of the day, get a good solid product to market. Power is obviously a huge area, and there's a lot of knowledge already in the space. What we're going to focus on mostly today when it comes to power is the right side of this slide, what we call sort of the end devices, or the edge devices, and also the unattended devices. So let me start there and ask you, Warren, what's new in the IoT, and where do you see some of the struggles that we've been facing and we believe that other ones are facing?
What's new is there's a lot of development kits on the market that allow a person, just one person, a hobbyist, to bring a demo up very quickly for an idea that they may have. The challenges are then going beyond that. Those demos often are not really power managed. You're plugged into the wall just to prove that you can get the features you need out of your idea.
You often mention unattended devices versus battery devices versus charged battery devices. Can you explore a little bit more around what you mean there?
Yes. So many devices we think of they're handheld or they go with you. They're wearable. They need to be in a form factor acceptable to the person, which often means they're going to need to be plugged in and recharged frequently. Other devices are mounted in a fixed location, but still generally accessible, and you may need to be replacing the batteries, hopefully infrequently. And then a third category of devices are ones that are generally not very accessible, such as a monitoring system. It could be in a large factory, it could be agricultural, where you've got these devices spread out over a large area, and they're really not that accessible, so you really want the batteries to last as long as possible.
So when you categorize what type of product you're building, what are the type of power parameters that you optimize for or have to balance?
Certainly a couple of the things to look at right up front are the user interface to the device. What you choose the user interface may draw a lot of power, and the other thing is the responsiveness expected of the device. That'll play into your factors.
And what about connectivity, which is sort of the key thing that we're seeing more and more things are getting connected, and how does that relate to power?
Right, so when we're talking connected with smart connected devices, usually, so the trend is, of course, to go with an RF solution. And if it's sort of more of a personal device, then it's going to be a short-range radio, Bluetooth perhaps, Zigbee. The other sort of connected device that I mentioned would be, say, your more of your monitoring, where you're basically collecting data over a long period of time, and the user's not necessarily expecting to issue commands and get a response right away.
So responsiveness.
That responsiveness, or the latency, the other flip side of the coin is really kind of is one of the big drivers in power management. Because if you're talking using a radio, you really need to be able to duty cycle that radio. That means turn it off for the bulk of the time and turn it on for brief periods of time. It might be it's off for a second and on for a few milliseconds, and you go like that, and you save a whole lot more energy than if it's just constantly turned on.
What is it that's been setting people's expectations on some of the responsiveness for these things? I mean, we all have sort of experiences like the garage door opener or old school technologies where the responsiveness is very fast.
So yes, garage door openers, TV remote controls that have been around for decades, all those things have set the expectations. And in those cases, and in fact, the battery life, you typically get well beyond a year, maybe even 5 years out of those devices. And that's because they do one thing and they're generally off. They're turned on by touch. They turn on, transmit the command, and then they turn it off, and they may be off for a day or a week until they're turned on again. Nowadays, what people hold in their hand, they expect to have a whole lot more functionality out of that, and they expect to have two-way communications and compute power in what they hold. So that really increases the battery usage by many, many orders of magnitude.
So by compute power is interesting. The emerging IoT space when it comes to device kits and chipsets and so on are providing more and more compute power for edge computing. I want to move over to you, Rickard, and as a security architect, we hear a lot about end-to-end security. That's the way to go. So that systems need. How do you and Warren work together when it comes to security versus power? Because in a device, you have constraints of what you can do. Right?
Security itself is affected by the power budget at hand. Depends a bit on the security solution. If you're looking at computational heavy cryptography, then you're looking at pretty low response time for a normal ultra-low power device, such as that we were talking about. But of course, there are other options that usually hardware support, and that brings in a whole other different area with regards to, like for instance, if you have normally in ultra-low power devices, you have AES support in hardware. That's symmetric cryptographic solution with a known key, and that key is sensitive for exploitation scheme.
So when it comes to two sort of competing factors of an IoT system, where do you guys start, Warren and Rickard?
I think we start with power budget, really, looking at the features of the product and what's required, and what those features mean from a security standpoint and a privacy standpoint. That brings in certain requirements on the security solution, which in turn might impact the power budget. Like, for instance, higher performance microcontroller, additional specific hardware, certain solutions, things like that.
Right, but in certain applications, the data is not all that sensitive. The temperature and humidity in your cornfield, for example, you might not need to go to great lengths to secure that data.
So let me switch gears a little bit. We have a saying here at Room5, a demo is not a product, and I think we've learned that the hard way many times. So I want to share with the audience some of the thoughts, and it's really related to power and security. And perhaps Rocky can tell us a little bit more what you mean demo is not a product and how that relates to power and security.
Sure thing. It certainly goes to some things that you had mentioned at the beginning and Warren also mentioned, which is there's a lot of support out there now for bringing pieces of a solution together quickly. A lot of connectivity, Bluetooth, cellular modem, Wi-Fi modules you can buy with stacks that are up and running very quickly. So you can put together a demo of an IoT project that has some simple firmware, a few sensors, shows the basic functionality you want against a mobile app or a server or both, and you can do those things relatively quickly. And that's good because it's a very fast-moving space, and you want to be able to be agile and develop and test those functionalities quickly. The thing to keep in mind is that the thing you just developed that way was a demo, and as you said, our saying is that's not a product. There's a couple major things to keep in mind. First, when you did that quick demo, you weren't constrained on the power. You didn't have to meet security constraints. Right? You're basically just demonstrating some fundamental connectivity. So you dodged two of the biggest problems. You also aren't delivering a real product in the sense that you have a lot more robustness requirements on a real product. And for example, particularly once you bring in mobile apps, now you have the issue that on a demo, you could pretty much get it working on your phone, one specific device, an iOS 5 or one Android device. A real product, of course, you want something, for example, that would work on a major portion of the Android devices out there. So now your testing burden has gone way up. So the effort that it takes to bring that to full product level quality is easily one or more orders of magnitude bigger than what it took you to do that.
So we heard that you guys can be ignored in your early stages, Warren and Rickard. So how, for instance, Rickard, how do you work with security when you're not part of the demo per se, but still that's going to be one of the critical aspects of the product?
In that scenario, what you need to understand is demo is mostly discarded whenever you try to move the product. In the demo scenario, you don't need to worry about security or power. When you start moving over to a product, you have to really start looking at the security aspect. You have to identify the use cases, what kind of requirements you have on security, and how that impacts the overall system design and the hardware selection. There are also other scenarios which you might want to look at, and that's things like remote updates, for instance. How do you secure that to make sure that no one doesn't deploy a custom firmware to your hardware? When it comes to security, it touches on basically every aspect of the whole system, and it's not something that you can just add on later. You have to really have a fixed mindset from the get-go.
Does there tend to be a one-size-fits-all solution? Is it relatively straightforward to build a platform that secures things end-to-end always?
No, the problem here is that when it comes to ultra-low power devices, you're often stuck with an RTOS at best, which means there are no packaged solutions for end-to-end support for security. So you basically need to hand tailor that, and depending on what kind of security level you need, you might actually want to discard privacy in some cases for responsiveness.
And how does that impact power, Warren, again?
Well, when you start, so you have your demonstration unit or your prototype, you want to start from there and develop what's called an energy budget. It's basically a spreadsheet. You put in each of the components that you know that draws some power, and read it. You can read that off the data sheet, and put in a guess as to a duty cycle. And so then you do the math in your right column is how much energy is dedicated to that component. And then you can turn that into a pie chart. And you can see the slices of where the largest energy is used. And then you start with the largest wedges. If it's the microcontroller, you look at that was chosen because perhaps it was handy, it was wired up to the right sensors you need for doing your demo. But if that's the biggest component that has a lot of extra compute power you don't need, you can scale that micro down and replace it with perhaps the same one from a different one from that family, same manufacturer, but just lower the power, or maybe you'll have to jump to a different family or a different manufacturer.
But there's a good point about the interaction between the two, right? Which is, if you don't know what parts of the system you need to secure at the beginning, or how much compute power you're going to need for that security at the beginning, and you underestimate the processing power as you're trying to cut the power budget, you can end up with a solution that can't support the level of security you really needed for what the end user is really looking for in these cases.
You know, I think the audience got the connections between power, security, and overall system, but let's dig deeper into that. I mean, I know you're a big fan of, designing one system, and would you like to explore a little bit more on that, Rocky?
Well, sure. Certainly one of the things that you alluded to early is that the complexity of an Internet of Things product is much bigger than earlier kinds of engineering on consumer products. In part, that means that it's a cross-disciplinary development effort, right? You've got firmware and hardware and mobile app development and in many cases server development. Those are all different domains that have different constraints. It's important as part of that development process that there is a single entity basically responsible for making sure that all those things are included in the design and that trade-offs among those different components are done in a way that meets what the end user is after. For example, there's oftentimes you can make a choice between where you put some processing on the server side or on the firmware side. There's good choices you can make there. It depends on whether you're trying to get more functionality. For example, if you have a factory that's got a lot of environmental sensors scattered all over it, then maybe a little bit of processing of that data on the sensor makes sense because it unloads the server, or more importantly, unloads the bandwidth between them that matters for Warren's power budget. So it's really important that there be a product owner of that overall system. And because there's so many different disciplines in there, that can be a challenge. And a related issue there, and it goes to something you said earlier, that there isn't really a sort of off-the-shelf Internet of Things platform right now, and that's in part because there's an enormous range of different kinds of Internet of Things products, and they require different kinds of teams and different kinds of solutions. So again, if I can jump back to Warren's environmental monitoring is a good one because there's a case where the hardware and firmware can be very easy. For example, if you're just tracking the temperature of some process or something simple like that. You maybe only need one guy on the firmware team. But maybe the mobile app for that has to be really complicated, showing you all kinds of historical data or letting you slice the data different ways. So there could be, 40 screens on that mobile app. So you could need a big mobile app team. That's very different than something like a smart toaster, where maybe your smart toaster has a lot of features and has an LCD display, and you really need to know everything there is to know about your toast. So that firmware ended up being very complicated. But the UI on the mobile app could just be a big toast button. So my point being that there's a lot of different ways to trade off the kinds of development and the kinds of teams you're going to form.
Going back to a toaster, that's a good example actually, because when it comes to security and privacy, data flowing from the toaster to the network might not really be critical to secure.
some people are not too worried about other people seeing their toast.
On the other hand, control of the toast is very critical because it's actually a fire hazard.
Right.
So there's a trade-off here between what could be considered as privacy versus security.
So that's a good example of the asymmetry involved between the two.
You know, it's pretty clear that, you know, we want to, from day one, design one system and have one owner of that system from a technical architectural standpoint. What about, you know, some tips and tricks, or what have we experienced that is good sort of know-hows around, you know, it's nice to have that intention when you start, but do you guys have any tips on how to make sure that we follow that through all the way to, you know, product release?
We certainly do have things that we like to do that we think make things work completely better in delivering a good product in the end. One of them, it's fairly standard software approach, but to take it on a cross-disciplinary team is another step, which is to build a working system from the beginning that has all the necessary data flow and communication among the parts. And then, even though it won't be functionally complete within all the parts, and then you can evolve that system as you iterate. That's a very powerful approach. The caveat that goes with that is on these cross-disciplinary teams, there's going to be very different natural development approaches and development cycles. For example, on a mobile app, you can do fairly pure agile software development, right, where you quickly iterate on requirements, modifying UI as you go. Conversely, if you're working on the hardware end, then a lot of what Warren was alluding to is very important. You've got to design that hardware up front to be able to deliver eventually the kind of power constraints you need to meet. So the hardware cycle has more upfront loading of the design and development and a very different iteration cycle.
Well, I was just thinking back to our statement that a demo is not a product. So yet a demo is what? It's a proof of concept, and to show potential users and perhaps investors and all stakeholders that this is a good idea to proceed forward with. However, it's not necessarily the best approach then to just make incremental changes on that. You really may need to step back and say, this portion was throwaway, we need to redo it to really build a product out of it.
You cannot really state the importance of that enough, because the more you get right in the beginning, the easier it will be in the long run. And that means actually look at every use case. If it's security, what kind of requirements you have. If it's for remote update of the software, you need flash on the board. I mean, it's a complex system, and the more you get right in the beginning, the less hardware space you need, the faster you get to move.
So what I just said might seem to contradict what Rocky said, which is the agile approach of having a system up and working and then move it forwards. Yes, I still agree with that. It's just when you replace, so you have a system, you're moving forwards, and when you replace a portion of it with an entirely different implementation, you plug that into your running system to make sure that it's still, you still have something that's always running.
So I'd like to challenge you on or ask you a slightly different question. And there's a lot of development kits, there's a lot of off-the-shelf solutions coming out every single month, basically, from the semiconductor companies and the connectivity and so on. Why would one throw away a working demo and spin their own hardware? It feels like an unnecessary route. I hear the point you're making, but can you, Warren, for instance, can you share some more thoughts on that and why this is needed? Why not just take a dev kit, get my app working, and 3D print a nice little box, and I'm done with my product, my smart toaster.
That if in some cases that works, and that's the way you should go. The dev kits, they're great. They have their general purpose. They oftentimes have a lot of extra features you might not need. They might be lacking. What would be very important for your project is they might be lacking the sensor you need. So now you've got a wired sensor hanging off the side, which eventually you're going to need to package that together somehow. They're also, the form factor these many of these demo dev kits can be very small, yet you need to place it into an existing product, and so it might need to be thinner so that it fits, longer. I mean, the volume might be okay, but it's just the wrong size, the wrong shape, which would lead you to spinning your own PCB. And then, of course, if you're going to go to any volume, you want to not be purchasing somebody else's dev kit and including that in yours. You can save money by designing and building your own PCB.
So basically what you're saying is all the little nice demos that I have in my technology office are not going to be products.
Not products that sell in very large quantity.
That's why they're still in my office, I guess. Well, let's share a little bit with the audience about some of the common pitfalls that we either experienced the hard way or we avoided by just general experience in the area. Rocky, perhaps want to start?
Well, certainly one of the things we have learned is the importance of building in debug visibility early and for the life of the product. It's very tempting to try and jump to a product quickly, and especially if you have to do custom hardware, it's nice if you can do that in a single spin, but that has challenges. Particularly, it's very nice to have debug consoles that give you some visibility into what the firmware is doing while you're developing, and it's always tempting to try and take those out for production. The trouble being that you'll tend to have all your hardest problems to debug in production or in the field. So planning for some kind of debug visibility throughout the life of the project, including when it's fielded, if possible. There are constraints there, but that has been invaluable for us, and we can strongly recommend it. There are also challenges there with the trade-offs with that visibility and power, for example, and security. They add complexity to both those realms. But the value is the dramatic speed improvement in development and delivering robustness.
Any thoughts on pitfalls in security, Rickard?
The main point is basically trying to look at the security options early. You have to look at trade-offs you might want to do. I mean, if you want to go into specifics, if you look at different cryptographic solutions you have, end-to-end versus asymmetric encryption or symmetric encryption, etc. Both of these have trade-offs in the long run.
Let me ask you like this. I might be not new to IoT. I have an engineering department that I trust, but we haven't really worked that much on security, for instance, because our products haven't been connected. They've been embedded systems with a local user interface. What are your considerations for an organization or a team like that to securities? It's one of those sort of areas where everybody leans on experts. Can I become an expert? How do I approach that?
Well, with enough time, anyone can become an expert, but you get time to market, and you definitely need to have someone who has the experience and the know-how to make the early decisions. And also, it's good to have someone or an external firm do security audits on your solutions, so you can validate that your product is correct.
And that's a practice we always use, right?
Yeah.
Even if we are lucky to have you around, you still always get your work audited by.
Also, if you're focusing so much on hardware here and the issues around that, but when you take an existing product like a toaster and also connect it to the online, then there's a whole new domain coming into play here, which is the security server space, of course. And all the security requirement that comes into play there. How do you harness the server environment, etc. Coming from a hardware-centric company, we often don't have that experience. So that's also another concern.
Yeah, I mean, look at the recent breaches at various big organizations. A lot of them went all the way out to the point of sales terminal, but the actual breach came from the cloud or from the enterprise infrastructure. So that's a totally different attack vector than the actual little device itself. even though that one was the one exploited at the end of the day.
And it's a very, very big one, because if you exploit that one, you get full access to a lot of different devices.
Sorry, and it goes back to your original diagram at the beginning of that dramatic increase in complexity means a dramatic increase in the number of attack surfaces, right? Every new API between components is now something that you just have to think hard about. One, does it need to be secured? Two, if so, how do you secure it at the best cost in terms of literally direct cost for the bomb or power cost, right? So those are, again, part of the cost of that complexity scale. And
you also have to look at things like, you can always assume the server will always be hacked. There's almost no server in the world that has not been hacked. So you have to actually work with the assumption that you will lose access to server sample. Someone will penetrate it. And how does that impact your product? You also have to look at things like, am I too dependent on the server? That means if that gets hammered by a DOS attack, how does that impact my product? So there's a whole new spectrum of attack vectors coming.
Right, and again, that goes back to some of the feature level trade-offs you have to make for the whole system. How important is it that your hardware work if it can't connect? And if so, it has to survive not being able to connect for a minute, an hour, a year. They're all very different solutions.
And the funny thing is, this goes into conflict with another statement we had earlier with the thing that moving things off the hardware to where it's more easy to develop an app on the server. That has a security implication in itself. So
yep.
There's always trade-offs on this.
That's a really good one because, for example, to emphasize, anyone doing modern server development in a good language will have all the support of unit test frameworks. It's easy to do penetration testing against the server. Hardening servers is a known problem. So moving, and of course the server is a much more powerful processor. So moving processing there often makes a lot of sense. But as Rickard pointed out, it means moving data there to do the processing on. So again, it changes where the attack surfaces are, and that's part of what you have to consider. So
we talked a lot about security, designing a system, and power. One thing that I want to touch on with you, Warren, is assuming you have limited or you have constraints on your end device for communication, RF. What are some thoughts that you have about saving power but still having a responsive system? I know you talked about virtual connections. Can you explore for the audience a little bit more about that?
Yeah, so the reason we kind of focus in on the RF is because it's oftentimes a large part of the energy budget. It doesn't always have to be, but many times it is. And it depends on your use case for something that's portable, wearable. You're going to use likely an off-the-shelf solution, Bluetooth, Zigbee, and there may not be a lot of tuning knobs there for you, the designer. But if you're going with with an unattended device that's left somewhere to monitor, now you have the freedom to write your own. Essentially, you replace the Zigbee or Bluetooth software stack with your own, and it can be very simple. It might be once an hour, just report in. And so once you gain control of the radio, you can manage your energy budget to a great extent in that fashion.
But with the trade-off that once you take ownership of the radio stack, your software development effort just is totally bigger. That's the trade-off Warren's pointing at is you buy one of these nice connectivity solutions that comes with the software stack, and that's great, it gets it running quickly. And when you need to start pushing it, for example, for power management, it's another one of those things where you have to be ready to scale up the effort.
Rickard, you mentioned that your system, we can assume that your system will be breached or exploited. What can you do to protect yourself in terms of reverse engineering and breaches?
Well, hardening a server space is a well-known problem. There's many companies focusing on that specific. So I'm going to switch the context over a bit to the devices themselves. with that in mind, basically remote updating of the software stack on the device is basically the primary way to do this. There are ways to make sure that the software image you're flashing actually is a valid one. It's designed and authenticated by the company itself by using some kind of public key cryptography solution. That said, there's also other issues with the hardware itself. As most development kits or hardware solutions these days are well documented. It's very easy for anyone with any hardware experience to hook up a debugger or extract the image from the MCU or grabbing even memory data runtime. It's fairly easy. So if you build a solution that has all the sensitive data statically on the chip, you're vulnerable. That's why there's an issue with symmetric keys cryptography that, like AES, if someone extracts a key, then it has the same key access to every device. So that we mean in those scenarios, you need to have different keys and because of distribution issue. That said, there are hardware solutions, like for instance STMicro, as an example, that offers hardware protection. Those can go in different forms. Like for instance, it's impossible to hook up a debugger to it. If someone tries to read data from the chip, then everything will be erased. So there are solutions that protect you from scenarios like that. However, when it comes to remote update, it gets tricky because you start programming a protected device with a new image, it wipes everything, which means that in technical terms you need to run it for RAM. And then you're vulnerable for, like if the system freezes or resets, then it's a brick device. There you get sort of trade-offs, whereas, yes, it's secure, but I run the risk of bricking the device, which means in-field support, whereas not using these features and move security aspect to a different element like the server space. And that means changing the cryptographic solutions in the system. Basically, in one case, you can rely more on public key cryptography and validating remote access. So you don't need to verify or secure the hardware itself.
So we're running out of time here, and I want to just summarize. I think we've made the overall point to the audience that it's complex and trade-offs needs to be made. We've heard various different, how many dimensions these problems can have, and just power, security, and then putting them all together, you basically multiply the dimension with each other. So, Rocky, do you have any sort of closing comments on, as a solution architect sitting there, you mentioned some pitfalls, some techniques, anything before we scare the audience too much about how complex this is? I mean, there is some light in the end of the tunnel, right?
Absolutely. Certainly these are more complex systems, but engineering has been solving much more complex systems for a long time. The challenge here is that the Internet of Things base of technology and what's possible is evolving so quickly. So finding the right mix of being agile where you can and using some of the more heavyweight techniques for more complicated projects when they matter. It's important to try and keep that balance.
All right. Do we have any questions that have come in, Ms. Mills?
Yes, we do. The first question that came in, and I'm addressing this to the team, does using RFID help with the communication without using power?
So RFID can be useful in the right circumstances, and yes, it can be very low power. Notice, of course, it's incredibly low bandwidth, and incredibly low range. So there are cases where it could be invaluable, but it's not going to take the place of, for example, the RF solutions that Warren was talking about that are power hungry have considerably higher bandwidth. So RFID is not a direct solution in most of those cases.
Short-range pairing is an example, for instance, where it can be suitable.
There are very neat things you can do with RFID as part of a bigger solution.
Yep.
It often won't be your only connectivity issue.
Any more questions?
Yes, we certainly do have another question. This is a little long. IoT seems to need solutions which can be tailored, modified when rolled out into the field. OTA, over-the-air update, and software upgrade, including to reconfigure for different use cases, seems to be needed. How do you design and test such an IoT system when the final use case is not there yet? IoT needs wireless networks with nodes which are adapting to the needs automatically. How do you create such firmware operating system swarm network?
There's a lot to grasp. I think I can make a comment on that. I mean, my role here as Com5 is sort of following the emerging IoT space and looking at what's going on and how we can leverage that serving our clients. And there's a lot of different components of an IoT architecture that are very well developed. You have good connectivity solutions coming out now that cover different RF technology. You have the semiconductor companies, Intel, Broadcom, Freescale, and so on, that are pushing the limits on the ultra-low power devices and what they can do. I think the key thing, if you don't know your primary use case and you're looking more from an architectural standpoint, you got to design that modular. But there are reference designs coming out, the reference architectures. Cisco, for once, has a very, very good 7-layer stack, which sort of defines an IoT architecture at a very high level. And when you start looking at what are the startups doing, what are the big guys doing, and what is coming out of Silicon Valley, you start to see a pattern and categories of how we can put together these building blocks. It's not about reinventing the wheel. That's not the point we're trying to make. And I think it answers, this, how you customize it. Yeah, you think about OTA, you think about security. And there are a lot of good puzzle pieces out there. But just because the puzzle piece itself is a good piece doesn't mean that it fits very well with another one. And that's where, your experience and your architecting comes in.
And certainly the role of mesh networks versus more direct connectivity is something that a lot of people are looking at. And it's exciting, but just because there are mesh network solutions doesn't mean you need one for a particular product. I just want to emphasize a point you made earlier. You're not going to get one of these platforms that is the right fit for every project.
Well, in terms of OTA updates for new features or use cases that weren't even foreseen, that's essentially...
Okay, hold on, everybody. We have to wait for the train. Okay, restart.
That's essentially what we have with a smartphone and the ability to load apps. Is it can be repurposed for vast different needs that weren't envisioned. What we're talking about is the smartphone talks to some other device, this Nest thermostat, for example, that can be programmed over the air to do additional features, but in general, it's not going to go too far outside of what it was originally envisioned to do.
Certainly a good comparison that fits with that is the reason you can download lots of different apps on your phone is all your apps have a very similar interface and require very similar hardware. Right? You got a screen, you got user input either by touch screen or some other way, right? So there are approaches you can take. If what you're trying to do is field a more platform-like solution, in other words, Internet of Things across a broad range of hardware that you haven't even defined yet for part of the question.
Right.
But you have to,
the Nest could be reprogrammed to control your toaster, but it's not going to do the toasting itself.
Right. And it's not clear that it's a net good in this case that you add that indirection.
And I think when you look at consumer products, IoT is very sort of connected to the smart home today, and you have many different vendors. So interoperability is obviously going to be a key thing going forward. And I know that there's a lot of research, there's a lot of alliances and consortium working on how can we sort of apply the learnings from the smart home ecosystem into the home. And obviously, home is one of the early adopters, but long-term into the industrial part of it as well. So you can have your different design system interconnect, and there's a lot of techniques coming out there about software-defined networks, from the basic layers to big data engines and so on, to sort of, at the end of the day, what we talk a lot about here at Rfid with our clients is that my original webinar was about is that this is so complex, there's so many options. It doesn't mean it has to be hard, but you have to understand what you're trying to accomplish and take a more top-down approach than a bottom-up, picking the platform and then tying that into whatever use case you happen to figure out. So.
Okay, next question. Any upcoming RF technologies that are attractive in terms of battery life and range? Range is a big concern when we have one central gateway connected with multiple end devices. And increasing number of gateways means increased costs. Thoughts?
Right, so that's a case where you're doing monitoring of some sort, and your devices talk to your gateway. The device is not on the internet, the gateway's on the internet, or perhaps an intranet within your organization. So you want to increase the range. Either you can go with a mesh network, so you're hopping from one device to the next in the direction of the gateway, or to go with longer range, just the old standby, add a power amplifier, directional antenna, but that's about it. And again, take over control of the radio and program that yourself, so you're not going through the Bluetooth or Wi-Fi stack, which has an energy drain itself.
And that obvious, going for a mesh solution obviously implies that you have a decent density of nodes as well. The other thing that's, slightly off topic from this question, but I'll mention it anyway, is that what I've seen lately is that many organizations or engineers fall back to the well-known 2.4 gigahertz spectrum, right? But it's becoming in a different implementation challenge when you can find off-the-shelf components, connectivity platforms that work in the 2.4 gigahertz spectrum, but where you're going to deploy it is a place like, whatever, an airport or a very crowded space, and you suddenly run into tons of interference that you didn't design your system for, right? And so I think, personally, yes, there will come more off-the-shelf solutions, sub-gigahertz space and above.
Yes, there are the sub-gigahertz ISM bands that can be used, and you do get longer range. Those are somewhat, there's FCC challenges there to bring those to market.
Last question?
Okay, the last question came in via email. How do you map out the budget and schedules given the different rhythms or iteration cycles of hardware, firmware, and software?
It's an on-the-point question because it is a big part of the challenge, and it was one of the things we were alluding to, although we weren't talking directly about the predictive side of it when we talk about the different rhythms. Part of that estimation effort comes from doing use case driven design up front, particularly for the hardware. And that is, of course, exactly what we were alluding to, that the power and security have to come first. And then there's building your schedule to reflect the fact that you're going to have hardware iterations. And one of the harder decisions you'll have to make is when to decide to jump to final production hardware versus having a dev board that has lots of visibility, but no form factor. So there are real challenges there. And there's always, of course, for those who are familiar with software development, there's always a challenge between doing agile development and doing a predictive Gantt chart kind of prediction.
And I think one thing that I see as well is that I think it's very natural for most people in software and even hardware to think about the use cases and do a top-down approach to write your architecture and then build a plan. What's different in an IoT solution is because of the complexity, a lot of the use cases span all the different technical aspects of it. take a very similar analogy is taking something simple like sending a text message. It's at first glance very simple, but when you think about what's actually going on from your device to through the RF of your phone to the cloud and server transaction messaging and so on being routed to the right place, there's a lot of interaction before that little single line of text ends up somewhere else. And I think that's a key thing for all the use cases around smart connected product. That, changing the use cases as you do with most projects, you learn along the way, and you realize, if you're a user experience designer or visual designer, you want to change things, but it might have much more cost than just moving a button in an application from the left side to the right side here, and that's the challenge, right? And I think what Rocky pointed out earlier about designing one system and always having a functional system, do a lot of iterations with early integration on the system as a whole is a key to keep up with changing requirements, and as you explore more and more of the system, you want to change things.
I certainly think that's on point. And one other amplification I'll add is when you're thinking of building the budget, the schedule, and estimates, maybe a single best piece of advice is focus strongly on the functional partitioning of the system. That's going to have a big impact. And the closer you get to right with that, in this sense, by functional partitioning, I mean what we were talking about earlier, which part of processing goes on which entity among the different domains. Now you always have that problem in classic waterfall development, which I'm not recommending you try here, but you always have that problem of how to do that functional partition. But it's really important in IoT to at least try and tackle it as part of your original questions.
All right, Karen, I'll hand it over to you to close this little webinar.
Okay, well, thank you everyone for your participation, and I'm sure you'll be very excited to go back to your engineering/coding man cave. So,
do we get a couch for the man cave?
No, you don't get couches in man cave. Yeah. You have to stand. We work you hard. All right, so after this webinar, our participants, you'll be emailed a survey, and we would really appreciate your feedback so we can continue to improve our content. The next technical webinar will be about distributed edge computing on IoT. Please stay tuned for dates and times. If you have any further questions, please feel free to contact us, or if you wish to schedule a one-on-one discovery or strategy session with one of our IoT experts, please contact me, Karen Mills. My email is karen.mills@room5.com. My phone number is 760-585-9562. Thank you for your interest and your questions in today's discussion.